Couple things you're going to see when this is all done. Whoever you decide to go with, you're going to walk into a building at the point in time it's done correctly. You're going to probably be about 20% more lit than you are right now. So your foot candle average is going to be higher. If the design is done correctly, you're going to eliminate almost all the shadows that you currently have out there that your folks might be complaining about.
Out there.
Right? So we do what's called max-min ratios within the modeling, and we try to make sure that we're using specific types of distribution throws on each light fixture. So every light fixture has the ability to throw light in about 8 different ways, believe it or not. Okay. So that's one of the advantages of LED, is that we can really pinpoint where we want the light to go and how that light gets there. Okay? So when we design under the right criteria in eliminating shadows, getting better, higher light levels everywhere. And then we may make some other recommendations like, hey, instead of that wall being gray over there, if you paint that wall white, you're going to increase your lighting by 20% as an example. So there's some other things outside of just the lighting fixtures themselves that we may have some recommendations on how to better achieve the results you're looking for as a whole. So we use a software called AGI 32. It's a 3D modeling design software specifically for the lighting industry.
Okay. My
users are what we call super users in the industry. So we actually help the software company develop their software further above and beyond what their capabilities are today. And so we're in their feedback program. And so as we get in there, we can take drawings of your space, recreate your space in a 3D imagery, and then each light fixture has what's called an IES file. And that IES file is an electronic file that we can plug into a computer generation model, and it will show you exactly how that photon bounces out of that fixture and hits 3 different places in that room to then calculate the average illuminance of the room in that process. So I've got a few on video I could show you right now. Okay.
Wow.
Here's what this looks like. Here's what we call a pseudo color rendering of your facility. And a pseudo color rendering is going to give it to you in color modes, as in red being the brightest, blue being the darkest. And you can see visually
like a heat map.
Like a heat map, as opposed to just numbers on the sheet. You're actually going to see exactly how we're going to light your facility. And this allows us to see any dark spots or shadows in that process. And so we'll continue to go through and change out the IES files and pick a different fixture, a different throw to start to get those red spots red where we want them, and green where we want them, and orange where we want them, so that we can truly know going in that we're eliminating all those shadows. So this is a risk management safety play on your end as well, where you're gonna increase your quality of any products coming off your floor. You're gonna eliminate any parts in the manufacturing process that you may have had flaws somewhere along the way. Maybe we catch those flaws a little bit earlier. Northwest Hardwoods, we just finished doing their facility at the coast. The biggest thing they came back to us and said is that they are getting more per every foot of board they cut than they ever had in the history of the company, because they're able to see the flaws in the wood better and cut the flaws out. So
I can certainly understand.
So they're gaining product quality along the way in that process simply by having better lighting there that they couldn't achieve prior to